Welcome to yet another video on Core Java interview series. Today we are going to discuss on top 10 most frequently asked Core Java interview questions. So whether you are here for just preparing yourself for a Core Java interview or whether you are attending any interviews recently, this video will be helpful to learn and prepare yourself for the upcoming interviews. Uh, let's begin. So, one of the most important questions when it comes to the access specifiers or the keywords which are used. So, one of the most important questions is about final, finally, and finalize. So, basically, this name seems to be very similar because it's all like final, and then there is a finally and finalize. Uh, but they have their own purpose and it is used in a different context. Okay. So let's look at it at one by one. So final keyword, it's an access, it's a keyword which is used for variables, methods, and classes. Okay. So when it is applied for a variable, it behaves differently. When it is applied for a differently, as in it does the same thing, but it is applicable for variable, methods, and classes. Okay. Now, it's a constant, I would say, when it comes to it is applicable for constant, classes, and methods. Now, let's look at the very first thing. That is variable. Now, once you create a final variable, that value cannot be changed after you initialize it. Okay, and when you try to initialize it again the second time, you'll get a error or a compile time error over there. You will not be able to compile it. Okay, that's the final variable. Now, what is final method? So when you write a when you have a child class and a parent class, right? So let's say you have one method which is there in the parent class and you try to override that in a child class. If a method is marked final in the parent class, you will not be allowed to create a method with the same name and other variable, the exact structure of it. So you cannot override that particular method. So you will get a compile time exception over there, error over there. Now, when the same final keyword is applied to a class, it says that you cannot be extended. Now, basically, what exactly in Java is all we extend it, we modify that, and we write our own behavior, right? Now, this is something which actually restrict your classes to extend it. So, this is what actually it will restrict you to extend. It will not allow you to extend. Hope you are clear about the final part. Now let's look at the finally block. Now in terms of exception handling and in terms of clean code execution, right? Finally block is used for try along with the combination of try catch statement. Okay, so no matter whether there is an exception in the try block or not, the finally block will be executed. Okay, there are a couple of cases where this finally block will not be executed, but I will let you know. uh, let's say you have a try block and the catch block and then finally block. Okay, and you write a statement in statement 1 in the strike block and statement 2 in the catch exception class block, and then in the finally block you write the statement number 3. Now what will happen if the exception happens, right? So what will happen, the try clutch block will, if the statement is written before the execution of the exception, it will execute. But if it is happening just before the statement, the try catch block will stop from where the exception is happening and it will jump to the catch block. Okay, if you have written that particular exception handling case over there, it will execute that, and ultimately the final block would be executed. Okay, so as I mentioned, in very few cases the finally blocks will not be executed. That is, let's say you write a system.exit at 0. Okay, so what happens is that it is asking the program to shut down. So and in that case, whether you write that in the try block or any other location, right, it will not allow to go ahead and execute the further program. It will straight away close that particular, shut down that particular program. Okay, hope you got this finally keyword as well. Now finalize, this particular method is part of the object class, and it is one of the method defined in it. Okay, now it is used when you it is used by the JVM for garbage collection. Basically internally the garbage collection happens, but let's say for that particular object you want to perform your own logic of garbage clean up, right, activity. So you can write that particular logic inside the finalize method, and JVM will call that particular method whenever the object is applicable for it. Okay, the when you want to free the memory. Okay, so although you write this finalize method, it is no way guarantee it will be only executed when the JVM wants to execute it. Okay, like when you call garbage collection, right? So it will try to invoke this particular method. So it is better that you write that particular code and then you write the cleanup logic. Okay, let's look at the very next question. This is uh, I would say, if you prioritize or if you choose right the top 10 questions, this would be definitely be asked. There is no way the interview would miss this particular question when it comes to the interview process, right? So this is the most frequently asked, most asked question. How does HashMap works internally? Now, you all know HashMap is a data structure in Java which uses to store the value in the key and value pair. Okay, so when you try to create an HashMap, it basically creates an array of buckets. Now, you can think of bucket as a container. Nothing else, like it will store something as a value of a key and value. Okay. By default, what will happen? There will be a 16 buckets created in it. Okay, in a hash map. Now, when you're trying to put something in an hash map, there is a concept of equals and hash code method. So hash code method comes in picture when you have a key uh, for the each key, right? There is a, when you're trying to put a key and value, so key, when you're trying to put inside any of this particular bucket, right, it will first calculate the hash code of that, and then it will ultimately decide which hash code, which bucket it has to store. So hash code is something, a unique identifier as a key for it. So it will determine in which particular bucket it will have to store. Okay, so the location might change when you're trying to resize or the as and when the restructuring of the hash map happens, but it ensures that based on the hashing technique it will try to store it in the bucket. Now let's say you have an example apple, right? So uh, based on that particular apple, the hash code will be calculated, and then it will try to calculate the index which has to be stored in that, right? So let's say it comes to the fifth bucket, it will store the key and value in that particular fifth bucket. But let's say the hash code, okay, there is a concept of hash collision. Okay, so when what happens when a hash collision is happening, it will basically it will generate the same hash code for a different object as well, or might be trying to create a same object. Okay, so there is a possibility that hash code might be same for a different object as well. So when there is a hash collision happening, so it will try to store in that particular same bucket along that, like with that will be stored in the another linked list. Okay, so it will store in one next to that particular same key in the same bucket itself. Okay, now HashMap is actually internally it uses a data structure called linked list when you're trying to store it. Okay, so at a certain threshold level, at a certain level, uh, once it surpasses the threshold, it actually changes its internal structure. Like in prior to Java 8, it was throughout, whether it, like whatever it was the capacity, whatever the size, linked list used to be used up. Now when after Java 8 or along with Java 8, the internal structure after a certain threshold it is moved to a balanced tree. Okay. Now as I mentioned, there are multiple collisions happening for a key, right? So you try to now when you're trying to put an element inside an hash map, right? Similar way it will try to retrieve it also. So first it will try to first check on the hash code of that particular key. When you are trying to retrieve it, it will go to the bucket, it will check on like in the let's say there are two three elements or like the same hash code was created for that, right? It will go and check and it will call the equals method. So it will check the equality. First it will check the hash code, decide which index with the bucket, and then ultimately it will check for the equality of that particular object, and then it tries to retrieve it. Okay. There is a capacity, as I mentioned. Let's say 100 is a capacity as of now, and let's say the 75% of the capacity is filled up. So there is a concept of load factor and a capacity. So the default load factor when it reaches to the 75%, it the hash map what it does that it restructure its size of the array, size of the internal structure, and then it will double its the size. Okay. So those are all the keys which are already there in the hash map. It will be rehashed, it will be redistributed and reshuffled into the new buckets. Okay. This particular process it is called as rehashing. Okay. So it's quite an expensive process, because let's say there are thousands of them, and then you after a certain threshold, like let's say the 750, right? You again it tries to reshuffle it. It takes time, and then it is not uh, it's a lengthy process, but it ensures that your hash map stays updated and like properly organized. Okay. So it is to summarize what exactly the hash map does is that it's an array of buckets. It stores key and value pair. Now hash code and equals method is important. So in order to avoid the hash collision, you have to properly implement this particular two methods. Okay. uh, Collisions are handled using the linked list. So there is, let's say, as I mentioned, there are the same hash code which is happening for a different keys, right? It will be stored in the same bucket with the help of the linked list as a tree, right? Or a balanced tree, as I mentioned. Now, at a certain extent, as I mentioned, it will try to resize it, and it is called rehashing. Okay. Hope you got the concept of hash map, how it internally works. Uh, Among the collections, so definitely after revolving around the basics of Java, the OOPS concepts. Okay. He will try to come up to the section of collections, and he will try to ask you what kind of collections have you worked on, and when you try to name them, right? So ultimately he might throw a question around like explain the hash map, explain the hash set, or a specific hash set, or he might come up with a question, let's say this one, which says that what is the difference between hash set, link hash set, and tree set. Okay. Now when you're trying to look at it, all this particular implementations are of set. Okay. Set interface. Now basically what exactly set is that it will try to store the unique element inside it. Okay. Like in array list or the list implementation, there is no check of duplicacy. It will try to store as many duplicate element inside it. But in set, it will not try to store the duplicate. It will try to store the unique elements. Okay. There will be a ordering, performance, and like internal data structure will be used for it. But let's look at the first uh, collection, that is hash set. Now, if you see underneath the set, it uses a hash table. Okay. So there is no specific ordering when you're trying to put an element in it. It is unordered and unsorted. Okay. But the time complexity of it is 0 of 1 for adding, removing, and contain. Like when you're trying to check like if it is contains an object or not. Okay. Now, uh, when to use this particular hash key. So when you doesn't have an it doesn't matter the sequence or the order, right? In that case you use hash set, and you need to access it very quickly. So in that case you need hash map. The advantages of using hash map is it's quite, when you're trying to perform some basic operations, it's best. It is you it as there is no filter of ordering or sorting, right? It will have the best performance. It will allow the null elements to be stored in it. Okay, so there is no only the point is the hash set is, it does not store in the iteration order. Okay, now second collection what we are looking into is linked hash set. Now again, the underlying data structure, what exactly it uses is the combination of hash table plus linked list. Okay, so here in hash set it was there was no order was maintained, but here the insertion order, when you're trying to insert it, it will maintain the insertion order. Now when it comes to the time complexity, it is 0 of 1, O of 1, sorry. It will behave for O of 1 for add, remove and contains. It is slightly when it compared to has said, it is slightly slower. As I mentioned, it maintains the insertion order. So there is some time which goes in the insertion of order. Okay, wherever you require that particular insertion order to be maintained, you can use linked hash. Okay, so iteration order is maintained over here. Okay, but it is slightly lowered as performance when it compares to the hash set, not tree set. Now tree set has got a internal data structure as a red black tree. It is one of the balanced binary search tree. Now it will maintain your order in the natural sorting order. Let's say you have an alphabetical order or using the numbers, right? It will be maintained in the natural sorting order. Okay, not in the insertion order, but in the alphabetical or insert natural sorting order. That is an normally that it's an ascending one. Okay, it will store in the or it might make use of the custom comparator also, where you can use it. Okay, where you can compare, make use of the compare method and then store it. Now time complexity is O of log n. So when you're trying to perform add, remove or log n or contain, right? So element which are needs to be stored in a sorted order, we make use of the tree set. Okay, if you want to maintain the insertion order, you make use of linked hash set. But if you want to store in a natural sorting order, you might use the tree set. Now keeping element which are in sorted and in the custom comparator also, we can make use of the compare method and apply your logic over here. uh, as I mentioned, it will be as your as there is a filter of sorting, it will be little bit slower from both the previous, that is hash set and the links list. Okay, uh, that's the disadvantage. uh, Here is the comparison what I have done. Okay, so you will not be allowed to store any null value inside the tree set. Okay, but hash set and linked list, it will allow one null value. Okay, so this is the comparison. Now this is used to be the most frequent questions, comparable and comparator. Now out of 10 interviews, definitely out of 10, 8 interviews will definitely have this particular interview question. Okay, so this particular is used to in terms of sorting, right? So it is when you want to sort something. Okay, or sorting the certain objects, either in the natural sorting order or either you wanted to have your own custom sorting order, you make use of this particular two interfaces. Now these two interfaces are used in a different context. Okay, they serve our different I mean, it has got their own implementation. Okay, let's look at it now. Comparable is an interface. Okay, these both are the interfaces. It has got a different there is an compare to method inside it. Okay. Now if you wanted to insert, if you're trying to insert and you wanted to maintain the natural sorting of an object, okay, so in that case you use that particular comparable interface, okay, and you will able to only compare with a certain uh, attributes of it. Okay. So you should be implementing this particular comparable interface when you're trying to implement. So only one sorting logic can be applied in it. Okay, we cannot have multiple sorting logic inside it. Okay, you must need to implement this interface and then you need to modify that particular write the logic in the compare method. Okay. Now how it works is that it compares the current object with the object we have passed it. Okay. So you will be able to only compare certain attributes. Now comparison is like, there will be three things. One is negative, one is the neutralize, that is 0, and one is positive. So when the current object, when you're trying to compare with the specified object, is negative, then it will be less than that. Okay. If it is equal, then both objects are equal. If it is positive, it means that the current object is greater than the specified thing. Now the continuation of the previous thing. Now what is comparator? So comparator is used to is when you want to have a very custom sorting logic outside your class. Okay. So it is uh, you can implement multiple sorting inside it. And basically if an uh, it is often used when you're trying to let's say you have an object, you have a comparator interface implemented in, and you want to sort it, right? So you can make use of this collection dot sort and that string dot sort, right? It is basically used for custom sorting logic. Okay. Now there is a method, earlier it was comparable, it has got the compare to method, but in this it has got a compare method. Now if you see, there are two objects which are getting passed in this particular parameter. Now you can create a different customized logic to compare different criteria on a different attributes. So there is no single attributes or a single logic you can use it, but here you can use multiple of them, the sorting logic. So there you doesn't need to change the original class. You have to just modify the you can extend it and then implement it, and then you can write your own logic over here. Okay. Same is applicable for the logic, whatever it is negative, positive, and the neutralize, right? So ultimately, it will try to compare, like if it is comparing two objects, if it is the first object is less, then it is like, it will be greater. The object two is greater. If it is object one is greater, then it will sort, right? It will move up. Now here I have mentioned, when you wanted to make the natural sorting order, go for comparable. Now if you wanted to sort on the multiple criteria basis, okay, and you doesn't want to modify your existing class, right? Then in that case you can use this comparator. Volatile keyword. Now this is one of the keywords, one of the important keywords used in Java. Whenever you wanted to ensure, okay, when it comes to multi-threading environment, and when you wanted to ensure that multiple threads, when you're working when you're given a task to a multiple threads and you wanted some data to be visible across the threads, right? So you want to that particular thread data to be visible to a different threads. So we make use of this volatile. So it plays a very critical role in terms of memory management. Okay. So you doesn't need to have uh, I mean for the each thread level, right? So it will be applicable for all, and it is visible for all the threads. Okay. Now as I mentioned, when we declare a variable as an volatile, one thread, if it is making a changes, it will be immediately be reflected to the other threads. There is no local caching applied over here. Okay. So there is nothing local, it will be completely visible throughout the threads. in this case what happens is that there is will be a less inconsistency between the threads. Okay, so when it is trying to read or write something inside it, right, so it will try to get the updated value. Okay, in terms of Java memory management, right, so it's quite optimized when you are trying to use this volatile keyword. Okay, now the what happens is that when you try to apply some value to a variable, there is a read and write operation now, right? So first you read it and then you write it. Okay, so it will be applicable for the main memory. It will read from the main memory instead of the local thread based cache. Okay, but when it comes to atomic reads and writes, right, so volatile variables are atomic for a variables of type boolean and int. Okay, these are all the variables which will be, but however, now there are some compound operations which we perform, right, like the increment of like the I plus plus or the increment the atomicity, right, that is not where the volatile keyword should be used up. Okay, so in that case, when you're dealing with the atomicity, where you're reading, updating, and then again update, reading, right? So in that case, it will not work. Okay, so in that case, you have to make use of the atomic variables like atomic integer, atomic things which are provided by the Java. Okay, so when you want multiple threads to have the same variables to be accessed and same data to be available, we make use of volatile. So you doesn't need to have this particular specific synchronized block of code where multiple threads, it will blocked up and then it will update at rep. So it will, the moment you update the volatile keyword, it will be visible to all. So there will be less inconsistency when it comes to threads. Uh, you might get questions around the string, what is string, or why it is immutable. You might also get questions about like what is string buffer, or what, when to use, why not to use, in what case you would use. Okay, so different interviewer would definitely would touch base about the questions around this string buffer or string builder. He might not ask all three of them, or he might touch base all three of them. So depend on the interview, you might get this, but definitely there is one or two questions to string related thing. So this is one of the interview questions when it comes to the core Java basics, right? To understand whether you have really worked as in basics. Okay. Uh, so let's start with string. Okay, so what exactly is string? Okay, it's an immutable class. You already must be knowing it, and it is part of the java.lang package. Now, what exactly internally it happens that once you create an object, okay, okay, so what happens is once you create that particular object, no matter what happens inside that particular memory, you cannot change that particular value. Okay, you can reassign it to a different value. Okay, but you cannot change that particular whatever it has been created. Okay, let's say you created two objects with the name, or let's say the literals as string. Okay, now you're trying to create a second object with the same with the string literals. What happens is that the second object will be pointing to that string only, or that string reference. But let's say you're trying to modify something, you to perform it something, and then you try to create it, then new object will be created. It will not try to modify the existing object. So that is what immutability is about. Okay, so it will be stored in the string pool. So there is a string constant pool which actually is used for the memory optimization. So it's quite thread safe when it comes to string. Okay, so that is the reason it is used in when you're trying to store an element, a key value pair inside the hash map. Okay, so it is thread safe. It is quite safe to use it. It has got a performance enhancement feature, like it's quite memory optimized. Okay, so when to use string is that when you wanted to read or frequent reads, right? And not frequent updates basically, okay, because you're trying to frequently update a string, it will ultimately create a new object, not the it is not going to modify the existing object. So if you want to save something for the multiple objects creation, make use of where there is a frequent read option. In that case you use, okay. So in terms of memory usage, it is quite optimized, and it is little bit it's quite fast in reading, but when it comes to extensive modifications, like you're trying to perform some operation appending, you're trying to add something, right, it's quite slow. Now let's look at the very second component, that is a string buffer. Now string was immutable, but string buffer, it's mutable. It means that you can modify that. Okay, it is part of the same package, that is java.lang. So it is thread safe. Okay, when it comes to the structure, but it's all methods are synchronized. That is the reason when you're trying to perform some action inside the string buffer, it is all synchronized, it is thread safe. Okay, so it's quite mutable, it is mutable. So unlike like strings, uh, like it will have the same capability of strings, but it is mutable. Okay, it will not allow, it will create a frequent new objects when you're trying to modify it. Okay, and also it is thread safe. It will store every object inside the heap memory only. Okay, so like if you see in the string, it will be stored in the string pool, right? It will be, this will be stored in the heap memory. Okay, now when there is a requirement of thread safety, you will choose string buffer along with the modification, frequent modification, right? You wanted to have a frequent modification, you want to make use of the utmost performance of the memory, right? So we can make use of this particular string buffer instead of string. Now, as I mentioned, it is quite efficient when it comes to compare to string. Okay, and it is now we haven't discussed about string buff builder, but when you compare, because it all of these particular methods are synchronized, right? So it has to first acquire a log, then it to perform that particular operation and then release it, right? So it takes little bit time. It has got little bit overhead of synchronization. Okay, so definitely it is it's best, but when it comes to comparing with the string builder, it is quite little bit slow. Now we'll discuss about string builder. So this is again a mutable class. Again, it's part of the Java Lang package. It has got similar features as of string buffer, but only thing is that it is not thread safe. It has got no synchronization. Okay, so wherever you want that particular modification to happen, and you are not worried about thread safety, okay, and you're not you're trying constantly modifying the objects, and you doesn't want that particular new objects to be created, you want to make use of the utmost memory utilization, you can make use of builder. So there is no synchronization, as I mentioned, it cannot be shared among multiple threads. So use it quite diligently when you're trying to work with multiple threads. It's not the cup of tea when you're dealing with multiple threads. Okay. So same as similarly, it will, how it is used to be stored in the heap memory only, as similar to string buffer. The use cases, as I mentioned, when you're not doesn't you want the thread set to be the priority, it can be used. And when you are frequently modifying let's say in the single threading environment, right, it can be used. Similar to the performance, if you see memory utilization, it is similar to the buffer, string buffer, but it is quite faster than string buffer, because it has no overhead of synchronization, there is no locking happening. Okay, now when it comes to this three of them, right, as I already mentioned, string is used when there are frequent reads and there is less modification. Okay, it is used for constants, keys, messages. Okay, but let's say you wanted to use for when your requirement is thread safety and you wanted to use in the multi-threading environment, there are frequent modifications, you use StringBuffer. But let's say you doesn't want you want frequent modification, but there is no requirement of multiple threads, right? So single threads are existing, so you use string builder. Okay. Now, in terms of memory management, garbage collection, you must have heard of memory management, right? JVM parameters, where you have that XX parameter for the lowest memory to the highest memory, which can be used up. So, Java, it has got their own internal memory management system. So, there is a garbage collection which internally as a domain daemon thread it runs, right? So it automatically checks out for the memory, the heap memory, the stack memory, the string pool memory, wherever the objects are available and to be revised, to be chunked up, right? It make use of that and then it releases it. Okay. So there are different memory locations. One is heap, one is stack. Okay, and there are different, inside the heap only there are different several regions. We'll come across that, but whatever, when you're trying to create an object, when you're trying to create a class instance, those will be stored in the heap memory. Okay. Now stack, when you're trying to create call multiple methods. Okay, some primitive data when you're trying to create, those will be stored in the stack memory. Okay. Now, as I mentioned, there are different sections inside the heap memory. There is a young generation. When the new object is created, it will ultimately stored in the young generation. Now, as I mentioned, the garbage collection that performs a cycle. Okay, it performs one cycle, second cycle, and then ultimately the objects which are living for a long time and it is not getting garbage collected, ultimately it will move to the permanent generation space. Okay, that is called uh, uh, used for the object which are living long. Now old generation, as I mentioned, it is called old generation. So there is a meta space which is used for storing the class level metadata information. Okay, so whatever the garbage collector main use is that it will be using, it will remove all unused object, it will try to reshuffle and memory optimize the memory whichever it is there. Okay, this is how memory management happens in Java. In terms of exception handling, now overall when it comes to Java, right, there is a basics is like oops concept is there. There are string, there are interfaces and abstract classes. So along the line, uh, this interview will try to touch base all these sections, right? Serialization, collections, oops concept, etc. So one of the important section is exceptions. Okay, there might be any questions around like name some text exceptions, or how do you handle try class exception, how do you handle exception in Java, right? What is try resource, what is try and a catch, and finally block. We discussed finally blocked earlier, right? There can be any questions around it, but this is one of the let's say he wanted to understand whether you know the difference between the checked exception or unchecked exception. He might ask you this question. Depends. But this used to be one of the important questions uh, long back, and like today it is relevant as well to the freshers or the initial level when you're trying to start your career, right? They will try to know whether you are aware of this checked exception and unchecked exception. Okay, so exception is nothing but like it's a in a program where you're trying to run certain program as task, and let's say some exception occurs or some uh, it will break the normal flow. There is something which has not happened as per the expectation, the core flow, and there is something which is not run as per expectation. Okay, so that is where the exception comes in picture. So those are categorized into two categories. One is checked exception and one is unchecked exceptions. Okay, so we'll try to see what is checked exception. So exception that are handled at compile time. Okay, which will not allow your class to compile. Okay, that has to be handled by the programmer itself. Okay, either in a try catch block, okay, or a try with resource, or either you are writing the signature method signature with the throws clause, right? You can use that. Okay, so first importantly, it will not allow you to compile it. This has to be taken care when there is a certain piece of code which asks for this particular exception to be handled, either by chaining it up to the throws method, throws keyword, or you write a try block. Okay, so you should have a backup where certain exception is throwing in, what you do, how you handle that, right? So it should be recoverable. Okay, so that's what the main concept of exception handling. So the very basic checked exception or IO exception, let's say you're dealing with file SQL exception, we are dealing with databases, class not found, we are dealing with classes when you're trying to load some classes, file not found, when you're trying to load some files, say, from the system uninterrupted, when you're trying to work with the threads, right? So these are all uh, exceptions which are compiler enforces you to take care of when you're trying to code, right? So these are used. So when you will use checked exception is that when you're trying to force the developer to handle this particular situations or problems which might occur, you make use of the checked exception. Okay, so whether you're trying to access the files, databases, network, these all exceptions are mandatory to be handled. Okay, now it comes to unchecked exception. This is also called as a runtime exception. So whatever exception which are not in our what do you say, in our scope, right? Or we cannot handle them. Those are the unchecked exceptions. So this might occur where you have not, let's say you're trying to divide some number with a zero. This is not something which you might expect and to do that, but this will ultimately uh, uh, happen, right? So what happens is that it will throw an exception, right? So that will throw an arithmetic exception. So here the compiler will not force you to write that particular, because compiler itself will not be able to understand at that particular compile time that there might be a possibility of an error. So that's the reason it doesn't imposes you to check that. So but you might write the logic to handle those particular exceptions. Okay, so let's say uh, null pointer exception, the index out of bound exception. So this kind of exception you might handle it. Okay, so these are called runtime exceptions. So they occur when your program is getting ramped up, and here when this particular exception occurs, right, there is no way that you can recover, right? So the logic will stop, right? So developer may or may not use this particular try catch, right, to handle this particular thing. So some of the common exceptions are null pointer exceptions. So you can deal with, like, you can write an exception block where you can deal with this null pointer exception, let's say, okay, or you can throw that. There is an index or except bound. So what happens is that in an array you're trying to access the elements which are not there. I mean the index, let's say, that is not present. As I mentioned, arithmetic exception, right? When you're trying to do divide by zero, illegal argument. So there is an invalid argument which you're trying to pass in the number format. You're trying to deal with numbers or string interchange, right? So you're trying to convert those things. So simply when your code is like, cannot do anything over there, right? So these are all null pointer exception. You will not know that, when the null pointer exception happened, right? So in that case, you use unchecked exception. Now, what is deadlock? Okay, so and how you can avoid it? Okay, so deadlock is something when let's say you're dealing with multiple threads, and one thread is trying to acquire a log on a certain object. Okay, and the same thread is trying to this different thread is also trying to acquire a log on another object, right? So what happens is that this both thread will wait for the so let's say a thread 1, okay, is trying to it locks the resources a, but then it waits for a resource waits on the resource, that is the resource b. Okay, now thread 2 want to acquire has acquired a lock on the thread b, but it is waiting for a thread to a to the thread 1 to release the resource a. Now in this case what happens that both are waiting for the another thread, another object to be released up by the other threads. So in that case the deadlock happens, it will keep on waiting, there will be no way where this will be handled. So in order to avoid this, okay, so the locks are used up. So there are try log which is used without timeout, right? You can use synchronized block to make where single thread will be entering that particular block of code, so the other thread will have to wait until the lock is released. Okay, so it will not happen that the same sets of code will be accessed at the same time. Okay, so this way you can avoid. Now, what is the difference between an abstract class and interface? So this is an age-old question, and it is quite relevant, and it also frequently asked. One or another question would definitely be around it. Okay. Now they both are used in a different context, but one is completely abstract and one is at a certain extent it is abstract. So abstract is something which is where you leave that particular certain features to be implemented on your own, and then you let the implementer deal their own way of writing that particular logic. So some of the logic is abstract and then some of the logic is implemented. Okay, so these both differ in the context where it is completely abstract and one is at a certain extent it is abstract. Okay, so we'll discuss when to use what, but when it comes to the feature of the OOPS, right, the abstraction and the polymorphism, these two abstract classes and the interfaces are used. Okay, but they're completely used in a different context. We'll discuss that. Abstract classes, when it comes to the definition what exactly it is, right, so it cannot be instantiated. Okay, so whenever you're trying to create an abstract class, like a normal class, you will not be able to instantiate it. Okay, you have to use the base class. Okay, now you can have both implementation of the methods which are having some implementation. You can have a complete abstract method which are which is not concrete, I would say. So you can have both. Okay, so abstract keyword is used when it you want to define a class as an abstract. Okay, so you can have both abstract and non-abstract method. All the variables you can create the instance variables over there. You can have a constructor and a static method over there. Now when to use an abstract method? When you have a certain logic which you are aware of it and you want that particular things to be in that way, and you want to let the implementer and certain features you wanted the implementation to deal in their own way, but ultimately you decide the skeleton. Okay, this would be the core things which will be there, and it should be done, but some of them you want that particular things to be handled in the core way, and some you want that particular things to be handled in a modern, or the implementation how it is to be handled in a specific way, right? In that case you use abstraction app classes. Okay, so some of the methods you can have the default implementation, some you want can impose them to have their own implementation. In that case you straight away use that abstract classes. Now interfaces is completely abstract, it is something which is completely abstract, you will have no methods with the implementation. Okay, now in Java 8 there has been an introduction of default and the static methods, but earlier prior to Java 8 there was no provision of having it, but default and a static method has been introduced. So now after Java 8 and with Java 8 you have different methods, but earlier it was when you wanted to have that particular complete abstraction, and everything was to be implemented by the certain implementer, right? You make use of that particular interfaces. So as there is a shift from Java 8, right, Java 8 there is like, if you the introduction of Java 8, it has got default and static method. Now in Java 9 there has been introduction of private method also inside it. Now you can define the variables inside it which are public, static and final. They are all by default. If it doesn't mention also, it will be public, static, final. Okay. Now you must have heard of diamond problem. You can make use of this interface when it comes to multiple interfaces. Okay. There's a different way to handle the diamond problem, but definitely we can make use of that. Okay. So it's kind of a contract or a kind of protocol which we make use of it, and interface is used in that context. Okay. The continuation is that actually, if you see, uh, in terms of, when you're trying to compile these differences, right? Field level, when it compares to, you can have instances in the abstract classes. You can have only what public, static, final in the interfaces. Method level, you can have both. In abstract classes, you can have both. Okay. But by interfaces, there was earlier prior to Java 8, right? And after Java 8, post Java 8, there are differences. So prior to Java 8, there was only abstract methods. Now it can have default and static method after along with Java 8. Now in Java 9, there has got private method. Okay. Inheritance. It is used for single inheritance. There is no multiple inheritance concept. Where it comes to interface, right? As class is dealing, you can also extend only one class, right? You cannot multiple extend. You have to. There can be multiple base classes, but you cannot have the, one class extending multiple classes, right? So yeah, the other case of interfaces, you can implement multiple interfaces, right? Constructor. Now constructor, you can have constructor in the abstract interface, but you cannot have an in the interface, right? Access modifier, you can have private, protected, public access specifiers. Interface, everything is like public abstract by default before Java 8, right? Um, Use cases, as we already discussed, you have some, base things, and then you wanted to have a specific things, you can go for abstract. But if you want for a complete, uh, you decide on certain behavior, I mean certain core things, but the implementation you want to leave it out with the implementer, right? You make use of this interface, but you want certain contracts, certain features to be available only, that we can use an interface. Okay. So when to use what is what actually has been discussed. Okay, thank you for watching. I hope this video was helpful to you. uh, it, uh, Thank you for watching.